What followed the disappearance of dinosaurs on Earth? Around 66 million years ago, during the end of the Cretaceous period, the planet lost its dinosaurs. We all know that this happened because of a global catastrophe, but most of us don't know what happened immediately after the mass extinction. In the video today, we will look at what happened in the first minutes after the dinosaurs disappeared. Watch till the end of the video to find out. No one could have seen the catastrophe coming. Dinosaurs stalked each other and munched on lush greens as they had for over 170 million years. Pterosaurs soared in the air, mosasaurs splashed in the seas, and tiny mammals scurried through the forest on what was just another day in the late Cretaceous. Then, the world changed in an instant. Imagine sunrise on the last day of the Mesozoic era 66 million years ago. Shafts of sunlight rake through the swamps and coniferous forests along the coast of what is now Mexico's Yucatan Peninsula. The blood-warm seas of the Gulf of Mexico teem with life. As this lost world of dinosaurs and outsized insects squawks and buzzes and whirs to life, an asteroid the size of a mountain is hurtling toward Earth at about 40,000 miles, which is around 64,000 kilometers an hour. For a few fleeting moments, a fireball that appears far bigger and brighter than the sun streaks through the sky. An instant later, the asteroid slams into Earth with an explosive yield estimated at over 100 trillion tons of TNT. Asteroids, for those who don't know, are large, rocky bodies that orbit the sun. They range from a few meters to hundreds of meters in diameter. Any fragment of an asteroid that survives landing on Earth becomes known as a meteorite. The air in front of the asteroid was compressed and violently heated, and it blasted a hole through the atmosphere, generating a supersonic shockwave. At that moment, the Cretaceous period ended and the Paleogene period began. By sifting through many layers of rock, experts are putting together a nightmarish vision of one of the worst days in the history of our planet. Some of the damage is easy to assess. The crater created by the impact is over 110 miles in diameter, a massive scar half covered by the Gulf of Mexico. But the devil is in the geological details at places around the world, such as signs of a massive tsunami around the Gulf Coast. The impact struck with so much force and displaced so much water that within 10 hours, an immense wave tore its way along to the coast. What settled out is a geologic mess. It led to ocean sand on what would have been dry land, and fossils of land plants in areas that should have been the ocean, in a mixed-up slurry of ancient sediment. In the part of the world where the tsunami struck, these layers mark a violent boundary between the last day of the Cretaceous and the first day of the following period, the Paleocene. Note that the effects were limited to the area of impact. The blast was enough to cause geological disturbances, such as earthquakes and landslides as far away as the current Argentina. As dangerous as the waves were to live in the Western Hemisphere, the heat was worse. When the asteroid plowed into the Earth, tiny particles of rock and other debris were shot high into the air. Geologists have found these bits, called spherules, in a 1/10 inch thick layer all around the world. The kinetic energy carried by these spherules is colossal, about 20 million megatons total, or about the energy of a 1 megaton hydrogen bomb at 6-kilometer intervals around the planet. All of that energy was converted to heat as those spherules started to descend through the atmosphere 40 miles up, about 40 minutes after impact. For several hours following the Chicxulub impact, the entire Earth was bathed with intense infrared radiation from ballistically re-entering ejecta. Earth became a world on fire. The friction of falling made each spherule an incandescent torch that quickly and dramatically heated the atmosphere. Any creature not underground or not underwater, including most dinosaurs and many other terrestrial organisms, could not have escaped it. Animals caught out in the open may have died directly from several sustained hours of intense heat, and the unrelenting blast was big enough in some places to ignite dried-out vegetation that set wildfires raging. On land, at least, much of the Cretaceous life may have been wiped out in a matter of hours. The heat pulse and its aftereffects alone severely winnowed back life's diversity. But the situation turned out to be even more serious. The climate impact was enormous. Dust and soot from the impact and fires would have created an impact winter with zero sunlight reaching the surface of the Earth for a year or so. Geologists can see this directly as a thin layer of soot that coincides with the layer between the Cretaceous and the Paleocene period all around the world. Organisms that had somehow managed to survive the intense heat and fires now faced a new threat. Loss of sunlight would have eliminated the phytoplankton base of almost all aquatic food chains and caused the complete collapse of aquatic ecosystems. Terrestrial plants were denied precious sunlight for photosynthesis as well. Like dominoes, this trailed up the food chain, causing the ecosystem to collapse. The reduction in plant life had a huge impact on the herbivores' ability to survive, which in turn meant that carnivores would also have suffered from having less food available. Breeding seasons would have been shorter and conditions harsher. All living things would have been affected in some way, both on land and in the ocean. All in all, what evolution was creating for over 180 million years was going to be destroyed in less than the lifetime of an individual Tyrannosaurus rex. Death came quickly at the end of the Cretaceous period. There is a lot of discussion over the actual kill mechanism and how long that period lasted. There are still a lot of unknowns, but it was a massive event affecting all life on Earth, from the smallest microorganisms all the way to dinosaurs. The casualty list is too long. Among them, ammonites, microscopic plankton, and large marine reptiles all died out, but the loss made room for the beginnings of the modern world. The blame can't solely rest on the asteroid. Before its crash landing, Earth was experiencing a period of climate change. This was making things harder for life on our planet. In what is now central India, there was a substantial volcanic activity that, although unrelated to the asteroid impact, was causing problems of its own. The resulting lava outcrop is now known as the Deccan Traps. For 2 million years, there was a huge amount of volcanic activity going on, spewing gases into the atmosphere and having a major impact on the global climate. There were also longer-term changes. The continents were drifting around and splitting apart from each other, creating bigger oceans, which changed the ocean and atmosphere patterns around the world. This also had a strong effect on climate and vegetation. The last non-bird or non-flying dinosaurs, if you prefer to call them that way, were living at a time of environmental change, some of which began millions of years before they went extinct. Now that we know that there was mass extinction, let us look at what survived after the asteroid impact. During the Cretaceous extinction, plants were less affected than animals because their seeds and pollen can survive harsh times longer. After the dinosaurs went extinct, flowering plants dominated the Earth, continuing a process that began and continues to do so. However, all land animals that weighed more than 25 kilograms became extinct. What was left was nothing but what we see in today's world. Most of the major animals that are alive today have suffered from some level of extinction. Initially, the survivors were small, with birds the first to experience evolution to larger sizes. There were a couple of lineages of gigantic birds, such as predatory and herbivorous, but they weren't around for very long and also went extinct. It was only around 15 million years after the non-bird dinosaurs disappeared, during a time that's called the Oligocene epoch, which is the time that we started to see really big mammals. This is when rhino-sized animals started to reappear. But up until that point, it's a world filled with small animals, especially in comparison with the dinosaurs that came before them. It took a while for body sizes to catch up. Dinosaurs remain the largest land animals ever to have lived. The only animals that have ever exceeded their size are whales. There is research to suggest that if the impact had occurred elsewhere on the planet, the fate of life on Earth could have been very different. If it had fallen just minutes later, the asteroid would have landed in deeper water, causing less rock to vaporize and rise to block out the sun's light and warmth. This would have lowered the chances of mass extinction. If the dinosaurs' reign hadn't been abruptly ended by an asteroid, we might have seen some around today. We are not going to deny it. We believe it would have been interesting to live alongside dinosaurs today. However, friendly dinosaurs. It isn't possible to be certain of the conditions after the impact, but it seems likely that it would have created a massive plume of vaporized rock. Within hours, this probably condensed into a rain of molten rock. This in turn could have killed most organisms out in the open and ignited global wildfires. That means animals in caves, underground, or in the water stood a better chance of surviving the first few hours. There are more than 10,000 species of living birds that are descendants of the survivors of the asteroid impact. But dinosaurs were already in decline. 10 million years before the impact, the number of species almost halved. A likely cause is the loss of habitats due to the retreat of inland seas and climate change caused by volcanism in the Deccan Traps on the Indian subcontinent. The remaining species of dinosaurs appear to have been doing fine until the Chicxulub asteroid struck. For scale, the Pinatubo eruption in 2001, which injected large amounts of ash and gas high into the atmosphere that spread worldwide, caused an average global cooling of 0.6 degrees Celsius. The asteroid impact had a cooling effect many magnitudes greater. If it was not for the asteroid, dinosaurs might have survived a little longer, although with modern birds, mammals, and reptiles starting to develop, they may not have dominated as they once did. With this last part, we come to the end of our video. We hope you enjoyed this video and your time with us. If you did, don't forget to like this video and subscribe to Mind Teaser for weekly uploads. Until the next one!